Hello guys, welcome back to the channel. Today we are here with LeetCode 153, find minimum in rotated sorted array. So let's begin our journey without any further delay. So here's the question. Let's read the question before starting. Given the sorted rotated array norms of unique elements, return the minimum element of this array. You must write an algorithm that runs in O log n time. So this is important here, O log n time. Input. So basically we have three examples. Let's see one of the examples. 3 4 5 1 2. So we have to write an algorithm in log n time so that we find the smallest element. So if it did not ask for log n time, what we could have done is check every element and find the smallest number. So but that will not be log n, that will be like O, and because we have to check every number if it is a smallest number. So in this case we can use concept called binary search. So before doing this question, let's see what binary search is. Binary search is basically finding an element in an sorted array. Sorted part is like an important part of this sorted array. So what happens in the binary search? Let's say we have a left pointer, we have right pointer, we find a midpoint, we shift the midpoint based on the target. If the target is 3, check with the midpoint, gives an answer. If the target is 1, midpoint is element as midpoint is greater than the target, so we shift our right pointer, we discard the other half, breaking the array into like half every time we iterate, and then again find a midpoint, check again until we find the answer. But in this question, the tricky part is the array has been rotated, so we just can't use our regular binary search. So what we could do is, let's take example 1 and example 3 from the question so it will be easier to understand. So let's see the, so the array should have started from here, but it has been rotated. This is not a rotated array or has been rotated 4 times. That makes the array rotated array same as the original array. So what we can do is compare our midpoint to the last element. So what does this do? Let's see. Element as mid is greater than element as last. So we know that smallest number is at right. And in this example, element of mid is less than element as last. So smallest number is at left. So we keep track. So we keep comparing to the last element and keep track of smallest number, so that we can return that number. So let's see this in a coding session so that we can better understand the question and how we solved it. So here is the coding question. So let's write what we are doing. Find midpoint, compare with last element, keep track of main value. So left equals to 0, right equals to len norms -1, main value, let's keep the main value as the largest number. Okay, while left is smaller or equals to r, find the mid, l plus r by 2 if, and keep track of main value equals to main of main value comma nums mid nums mid. So we're keeping it, we are comparing with the nums mid to see if it is the min value every time, to keep track of the min value. So if min nums mid is greater than nums minus 1. So what happens if nums mid is greater than nums at the last? So it means that our smallest value is on the right side. That means that we shift our left pointer, and else we shift our right pointer, and at the end we return the mid value. Let's try running to see if we have made any mistakes. Sorry, mean value, not mid value. Okay, it got accepted. Let's submit it. Okay, so the submission got accepted. The runtime is pretty good. So this was one of the techniques to solve this problem. If you have any other techniques, any better solutions, please let me know in the comments, and if you have any questions, you can comment down. And thank you very much for watching the video.